So welcome to the Department of Materials Science and Engineering. I'm Dan Blackwood. I'm the Deputy Head for Education and Student Affairs. So I'll tell you a little bit about the department and then about what you will learn here and why you should come and join us. Right, so what's materials science and engineering? I know you're all sort of familiar with mechanical engineering, chemical engineering and subjects like that. But we are actually sort of core to most industries. We're a mixture of science. There's still some coming in, some students still coming in. We're a mixture of science like chemistry, physics, biology, not so much biology, but certainly a lot of chemistry and physics, but we're more applied. So we work in the more industrial areas, so things like industry, soft robotics, biomedical, 2D materials. So if you like science, but actually want to feel it's useful, then material science and engineering is actually a good choice. Okay, a little bit of history of the department. We actually started in the Faculty of Science in 1991 as a program. So that shows how we're science-based. We became a fully fledged department in 1996, which is actually the year I joined. So I've been here longer than most of you have been born. And then in 2005, the university decided we should move to engineering, that we should have a more applied focus. So we still have a science core, but the university wanted us to have a more applied focus. And then in 2022, last year, the Faculty of Engineering became part of the College of Design and Engineering. That's where we are today. What we offer is a 4-year bachelor's degree with honors, direct honors, and it's accredited through what's known as the Washington Accord. This is a group of countries that come together and agree to recognize their each other's degrees. So your degree will be recognized in places like Canada, China, the US, the UK. This is not an exhausted list, and we'd recognize their degrees. So if you go overseas, your degree is still counted as a professional degree. Okay, what are we actually going to learn here? Okay, the total should add up to 160, not 40. So you'll have university requirements, which is like 20 MCs, 20 units. That's where you'll learn breadth and communication skills. And then all the engineering students will do another 60 units, which is the engineering core. And here you'll learn things like design, machine learning, computing. You'll do an industrial attachment for 1 semester, which quite a lot of our students enjoy. And you'll also do an integrated final year project. That could be a design project in a team, or it could be an individual research project in some of our labs. And then you will have 40 MCs of the MSc major courses, which I'll talk about at the moment, and where you're going to learn materials properties. And there's also 40 units of unrestricted electives. So a quarter of your units, a quarter of 160 are actually unrestricted. And I'll talk more about that at the moment and what to do with those. So what are you going to learn in MSc? Well, in the first year, you will just do 2 courses, what we call MSc Engineering Principles and Practices, where you'll get the background knowledge on materials. You'll learn the basic physics you need, the basic chemistry you need if you haven't already had that, and things like mechanical properties, different classes of materials. And this will be done in a mixture of lectures and tutorials. Don't worry if you don't have A-level physics or A-level chemistry. We actually will offer bridging modules as well, and you can use some of those unrestricted units for the bridging modules. So you'll be able to catch up if you don't have A-levels in the particular subjects. I won't go through all our different modules, but you'll see there's quite a lot of lab work. Okay, we have materials characterization labs. An important part of materials is to understand the microstructure of materials. So we need to know the techniques that we use to probe that. Also, if it was in failure analysis, how did the material fail? That's all part of materials characterization. Material selection and design. There's so many materials out there now. What am I going to make things out of? Right? So what do you make an aeroplane out of? In the old days, they were made out of wood or metal, but now we have a lot of composites, and which composites to choose. And the same with biomedical applications. Right? If you want to buy a medical implant, which implant should you make it out of? You need to consider, would it corrode in the body? Will the body reject it? will the body grow around it so it can actually be a proper implant? And those are all part of material selection. We also have machine learning again, so there's more AI. There was AI in the faculty core, but we also have AI in our own units. And also there'll be some technical electives where you can sort of start to specialize. And that's where I can actually talk a bit more about what am I going to do with these 40 unrestricted units, or what are you going to do with your 40 unrestricted units? You can actually do anything you like. You can do French or a foreign language or anything you like, but you can also sort of use that as a more focused approach. For example, you could use it for some of our specializations. Our specializations, you need 20 units to get a specialization. You can already use those 8 units of technical electives that we had back here. This is actually going to be 8 units of technical electives. So to get a specialization, you actually only need to use up another 12 technical electives. And we have specializations in things like biomedical materials. And this could include controlled drug release. You might think controlled drugs is about medicine, but actually what you need to have a controlled rate of drug release is a material that slowly degrades at a controllable rate, and that's a materials problem. It's not a medical problem. We also have one in nanotechnology, and examples of those are light-emitting diodes or lightweight carbon nanotube composites. Right, so these are used in these carbon nanotube composites are used in many industries where weight's important. They're starting to be used in aircraft and automobiles. We also have one in specialization in artificial intelligence, where you learn to use machine learning to develop new materials, perhaps to develop catalysts for better hydrogen production, or removing CO2 from the atmosphere, better catalysts for that. We also have a specialization in renewable energy and sustainability, and there students learn things like improved batteries and improved solar cells. And we also have 2 new specializations. We have one in robotics, which is now approved, and there it might be, how do you find a material that will give a robot a sense of touch? Touch is something you think is easy. You pick something up and it's very easy, but for a robot, how hard do you squeeze? You don't squeeze hard enough, it doesn't get picked up. You squeeze too hard, it breaks. And so you need to have a material that will give a signal. When you squash the material, you can make it give an electrical signal. And the 6th specialization we're going to have is microelectronics and quantum materials. An example there might be the quantum dot displays. This one's been approved by the university. It's now with MOE. MOE usually sits on it for about 3 months before giving their approval. So it should be ready by about end of July, early August. So it'll be ready for you. So what else can I do with my 40 units? Well, you might have noticed that the 40 unrestricted units, you can use those for a second major, or you can do a double degree. If you do a double degree, you actually need up to 200 units. So you actually would then take 4.5 to 5 years, depending whether you're doing single honors or double honors. But you can do a double degree in material science with economics, with business. You can do it with any other engineering department. In fact, when you do it in another engineering department, you actually still only need 160. But you can also even design your own double degree program. Okay, or you can have a double major. We have a whole list of double majors, so I wasn't going to go through the whole list. A second major is 40 MCs, so you've got those 40 MCs of unrestricted electives, so you can actually do a second major without actually having to take additional modules than what you would have done for just your single major. You no longer have a chance of perhaps doing a foreign language or something, but you will come out with a second major degree. And most of our students decide on whether they want to do these second major or minors at the end of their first or second year. There's no rush, because in your first year, you're doing mostly core engineering modules. So you don't miss out if you don't decide straight away. And what I've got here, what's that? this is an example of how we could actually a recommended schedule if you wanted to do a second major in computer science. Okay, so we can actually see if we can fit it within our 4 years and still do the 160, and you're going to actually have graduate with 2 majors, one in material science and one in computer science. And actually, the one I've highlighted here, this is a program methodology. This is actually part of the core engineering syllabus. So that double counts. So you actually still have at least one unrestricted elective you can take somewhere. You still do one course in French or something. In order to get on this program, you have 2 routes. You can either declare right at the beginning you want to do a second major in computing, or you can decide to join it after the first year. In order to get onto the program, this course, which is program methodology, basically teaches the Python language. You must get at least a B+ in that module to get on that second major. However, if you get onto the second major right at the beginning, you still need to get a B+ to stay on that second major in computing. So it doesn't really make any difference whether you join the second major at the beginning of your first year or at the end of your first year. What else can we do? Okay, this is a few of the minors. There's way over 100 different minors you can do. So I'm just showing a few that our students like to do. They like to do minor in business is being popular, computer science, economics, quite a lot. Because we're science-based, quite a lot want to go a little bit deeper in physics, so they do a minor in physics. So there's a nice worldwide spectrum of where you can do a minor. And you're sort of spoiled for choice, so sometimes too much choice can be difficult, right? Okay, so why choose material science and engineering at NUS? Well, one of the important things about NUS compared to any other university in Singapore is that we're a comprehensive university. That allows you to develop a wide social network, particularly if you manage to stay on campus. You will have friends, you can have friends from the law faculty, the art faculty, from science, economics. And so this gives you a social network which will stay with you for the rest of your life, right? In Singapore, when students graduate, they mostly stay in Singapore. So you will know these friends that you make, this network you make for the rest of your life. And this social network is as important to you as the technical skills that you learn. And NUS is the only university in Singapore that really offers you this ability to have this wide networking opportunity. There's no other comprehensive university in Singapore. We also have a fairly small cohort size, which means we have a good teacher-to-student ratio, so we can get to know all of you. We'll assign you all an academic mentor. So one academic staff is someone you can talk to, not only about your academic issues, if you have academic issues, but he's also someone you can confide in if you have any personal problems. Sometimes just having someone to talk to can help a lot. We know you're young and you're at the age when people start to have a lot of sort of social interactions for the first time, and they will have problems. So this gives you someone to actually talk to. We're very keen in NUS on promoting social wellness and learning experience. And then we have a flexible curriculum. We're strong in science, but we're also all about world life applications, right? Why do you need to study this material or this material's property? We'll explain to you so you know why it's going to be used in industries. And all industries need materials, as I will show a little bit later. And so this flexible curriculum, it sort of gives you some of the options that you might be able to do, right? So this is the engineering core in blue down here. Then you've done your major, material science and engineering in the orange. And then on the top of that, it shows some of the things you could actually do with your 40 units of free electives. You could do a specialization in materials and a minor in another engineering, or you can do a specialization in materials and a minor in a completely different area like economics or data engineering, or you can go on and do a minor in entrepreneurship, or you can do 2 minors. Actually, you could have done 2 specializations. We didn't have 2 specializations, but you can do 2 specializations. Or you can do a second major. So you can see it's very, very flexible. And all these will add up to the normal 160 units, so no need to spend extra time. If you want to do a double degree, where you actually come out with 2 degrees, then you will probably need the 4.5 to 5 years. Why else do we should you come to us? Well, there's all these rankings around, but most of them are research related, but the ones that are related to undergrads, we come out #1 in Asia in both. There's the Times Engineering, no, Times Higher Education, which says NUS Engineering is the top school in Asia. It doesn't actually rank by subject, it's just by the engineering as a whole. So we're the top in Asia for engineering, and MSc is the top in Singapore and Asia for the employer ranking. So the employers in Singapore like our students over the students, MSc students from other departments. These are all done by surveys. And then there's also employment. Our students do quite well in employment. We have 93% got employment within 6 months. And this is the salary. So these are the median salary and the top sort of salaries. And if we were to compare to other MSc departments in Singapore, you'd actually find that our students get a little bit higher salary. Not a great deal higher, but a little bit higher. And we're sort of in the middle of the other engineering topics. We're not the highest paid salary, but certainly away from the lowest. I can actually say we actually do slightly better than the biomedical. So if you're not sure when you'll do biomedical or MSc and you want a little bit more money, MSc is a little bit better. Okay, and salaries finally started going up. Okay, last year, students got around 12 to 15% higher than the previous year. Okay? So it's about time that Singapore started recognizing engineers and started paying them a little bit better. And that bit was a bit of good news. This is some of the employers. The university doesn't really like me showing this slide because I'm not supposed to show all those logos, but if I show them, you recognize them, right? So there's the materials and engineering technologies area, the traditional area you might find material sciences. There's also all the life sciences, so the biomedical industry. Procter & Gamble employs quite a few of our people. We have them, they go off into the things like Keppel and SMRT. They go into the research institutes. More and more are going into the aerospace industry. Rolls-Royce has a factory now in Singapore, GE Aviation. So there's a growing number in the aerospace. Oil and gas, you'll find students. This is the sort of solar energy or the energy market, more and more. They go into the microelectronics, is still a large employer, the semiconductor industry. But also we have quite a lot go off into banking and investment. So if you, well, when I was a student, I was actually chemistry because they didn't really have material science and engineering, they were only metallurgy or ceramics, so I did chemistry. When I was a student, all the top accountancy companies used to come to the chemistry departments to try and get students into chemistry, into accountancy, because they found that the analytical thinking skills that science and engineering students have meant that science and engineering students do better in professional exams than accountancy students do. I'm not sure, I graduated 25 years ago. No, that's a lie, nearly 40 years ago. So I'm not sure if it's still the case, but certainly engineering students, they learn the analytical thinking skill, which is very good for areas like accountancy and banking. So just because you do engineering, you can enjoy yourself for 4 years, and then you can go into the more boring accountancy areas. I have a lot of friends who are in accountancy. They make money, but they are a little bit bored. Okay, another reason to go into MSc NUS, we've got well-equipped undergraduate libraries. We have scanning electron microscopes, X-ray photospectroscopy, atomic force microscopy, X-ray diffraction, and hardness testers. The first four I mentioned, each one costs sort of somewhere between $500,000 and $1 million, and we'll let you play around with the buttons. Try not to break them, but so you will get hands-on experience of the high-end research equipment if you join us. We've got well-equipped labs. We're also very good at research in our department. This is what we call the highly cited researchers. Every year, there's a surveys done on whose research is cited. Worldwide, there are 6,600 researchers worldwide that are highly cited. of which 32 from NUS, which is good if you think how small Singapore is. 5% of the top researchers in the world are in NUS. And for that 32, 5 are in our own department. And we're only a very small department, so that gives you an idea that, right, what's that, nearly 15% of the top researchers in NUS are in MSE, even though we're a small department. And in particular, I'll point out our Nobel Prize winner, Costner, is the only Nobel Prize winner who works in Singapore. He won the Nobel Prize in Physics in 2010 for graphene. And now the government has put $100 million, and NUS has put $100 million into opening the world's first institute dedicated to functional intelligent materials, which we led by Costner. So you can see if the government's willing to put that amount of money, and NUS is willing to put that amount of money in materials research, you realize that they think it's important. And so it definitely is a good area to go into if you're interested in doing future research. Another reason to do MSc at NUS is we have excellent student exchange programs. You can spend a semester or two at one of our partner universities. We've got 300 partner universities in 40 countries, things like University of California, Imperial College in London, Georgia Institute of Technology, Tsinghua, University of Tokyo. And we're also the only engineering school in the world to have exchanges with both Cambridge and Oxford in the UK. I'm from the UK, so obviously I would encourage students to go to Cambridge or Oxford. Or you could perhaps join a startup. Right? You can spend a year during your degree at one of our overseas colleges where you can work in a startup. We've got overseas colleges in Silicon Valley, Stockholm, Israel, New York, Toronto, Nagoya. So you can see that there's a wide choice. If you're interested in entrepreneurship, this is a good route to take. There's also something known as the Engineering Scholars Program, okay, where you will, if you're a top student, you can join us, and you can do your BEng through that on an accelerated program where you do it within 3 years. And afterwards, you will also be able to take a master's or an MSc. So you would graduate within 4 years with a bachelor's and a master's, or you could do the double degree. The double degree program normally is 4.5 to 5 years. If you do it through the Scholars Program, you can actually do it within 4 years. And they will also give you extra courses in things like leadership. Okay, so they have their own specialized courses to replace some of the university requirements. The only downside with the e-scholars is it is quite packed. So you do need to be willing to study hard to stay on the program, because you're compressing 4 years into 3, but it's a good opportunity. Okay, so this is also, I talked earlier about materials design and selection. So this slide gives you some idea of how important materials have been over the years. Right? When I was in the Stone, I was never in the Stone Age. When we were in the Stone Age as a species, material selection was easy, right? You could only make, the only metal we had was gold. So you made it out of gold, wood, or stone. Now we have to choose out of hundreds of thousands of materials. So that's why this design and selection course is important. But also, as you go through society, you realize how important materials have been to the world. And that's also shown on this slide, right? We started in the Stone Age, a material. We went to the Bronze Age, bronze is a material, tin and copper. Then we went to the Iron Age, another material. Okay, in the more recent times, we started developing plastics, and perhaps we may still be in the Silicon Age, right? The age of semiconductors. It's always based on materials. And in the future, materials are going to be important. I don't know which material it's going to be. It's going to be probably intelligent materials. But whatever it is, the future is going to be some material and then age. So if you join us, you can hopefully be part of creating it. So that's my main message for joining us.
Thanks, Prof. Dan. So I guess we can move on to the Q&A for this session. So if you have any questions regarding material science or curriculum or second major specialization, feel free, you can unmute yourself, you can ask Prof. Dan. regarding, on your questions. Or if you are a bit shy, you can always write in the chat. So just address it to everyone in the meeting so that we know, so everyone can see the questions. So you can either put it down in the chat or you can just unmute yourself. So anyone has any questions?
You can always send me an email. You can find me on the MSE website. So if you have any curriculum questions, you can always email me.
How do I know which major is best for me, like right now?
Well, I would say the major that's best for you to start with is material science and engineering.
Like,
But
yeah.
were you thinking a second major or?
Yeah, I think the second major.
Well, the second major, like I said, most students don't decide until the end of their first year. So I think if you come to NUS and take time to decide what you want to look at, right, you can learn more about the other majors. In part, if you're interested, you can start trying to find seniors who have done the second major. But usually talking to your seniors is the best option. So I wouldn't rush into the second major. In the first year, you don't actually do any modules from the second major, so you can take your time. So at the end of the second year, you'll have a clearer picture of what you actually want to do, because it's a personal choice what you really like. But you can also discuss that with your mentor. That's one of the things you can talk to your academic mentor about.
Okay, thank you.
For minors, right? How do we apply for them? Is there any like guidelines to this?
Okay, that you can apply for them before you come, but again, most students apply at the end of their first or second semester. I'm not absolutely certain of the route by which you actually apply, but I'm sure it's related on the website. I don't know if either the student ambassadors, have you applied for a minor? You know how to.
So I did a minor in econs. I'm still doing it right now. You can apply it, first year or second year. You have enough time to finish the modules by then. Depends whether the minor is a restricted minor or an open minor. So if you're taking economics, there'll be an open minor. So you can apply whenever you like. But if it's business, then there are a few requirements that you need to follow based on the website. And based on that, you'd be able to apply for the restricted minor.
Do you know where to apply?
So you can apply from EduRec. So once you are in NUS, then you can apply, or you can apply directly on the portal itself.
Okay, thank you very much.
No problem.
Okay, maybe if there's no more questions, we'll move on to the next section.
So perhaps we will just move on to the next segment of this webinar. Right. But if you do have any questions, feel free, you can always ask after our student sharing. So first up, I think we will invite Zhongrui, our second year student, going third year student, to share with everyone his experience. Zhongrui.
So let me try and share my screen. You can see my screen, hopefully.
Yes.
Okay, so yeah, thank you, Prof. Vincent, for that. So yeah, I'm Zhongrui. I'm a year 2 MSc student now. So just want to share a little bit about what I have experienced in material science engineering after 2 years now. So who am I? Well, I graduated from TJ about 4-5 years ago. That was ages. And I joined MSc in about August 2021. So now I'm a year 2 coming year 3 MSc student. I'm doing a minor in econs, as I said earlier, and I'm actually doing, or rather planning, a double specialization. So if you want to know how I did that, you can let me know. I can tell you how I was able to plan my modules for that, but it's definitely unorthodox. So I intend to do one on sustainability and one on nanotechnologies because I'm interested in energy. And what is this Assistant Secretary of Numismatics? Well, that's one of my hobbies. One of my hobbies is coin collecting. So I was elected to the Asian Society. So yeah, that's one of my silly quirks about myself. So why did I pick material science? Well, three main reasons. So firstly, very small cohort size, close-knit, friendly community. Just look at me and all the profs, chilling together. And we are all very close, as one very united and very helpful community. I think even it goes beyond my mentor. My mentor is actually Prof. Blackwood. So I mean, there's mentors everywhere if you think about it. Everyone's so willing to help you. Everyone knows you by name even. And academics-wise, why did I say given breadth and chosen depth? The common curriculum will enable you to have a given amount of breadth in the course that you like and the studies that you like to take. You choose how deep you like to go, what specializations you like to pick, what minor or major you like to pick, and whether you want to have any overseas opportunity. The depth is up to you to choose, but that breadth is important for you to stay relevant in the future, which drives me to the third point, which breadth will give you that flexibility and applicability in the industry 4.0 in the future. This is why MSc was so central to my belief as a student. So how's my life at MSc then? Well, it's not just about studying. Well, I think Harini will talk more about this. I know she's prepared more about the student life. But for me, I really love the MSc events. I helped out in like the Save the Egg Challenge 2021 and 2022. The sports day, I know I look really tired in that picture. I was playing badminton for like 3 hours, so pardon me for that. But yes, we have a lot of events that we are united as one, and so we are really, really passionate about what we like to do. But really, what is in MSc for me, or rather what drives my experience in MSc the most is research. I am an undergrad somehow doing research since year one for some reason. So why and how? So I used to work on aerogels, and yes, I'm still working a little bit on zinc ion batteries. So I'm really inclined on energy storage materials. And you might ask, how can an undergraduate actually do research? Because, you're an undergraduate, surely that's reserved for graduate students like masters or PhD or beyond. So how it happened? How did this come to be? And I honestly didn't really think that I would be able to do any research until one of my friends in the department. So remember, we are a very close community. And my friend Trevor was like, hey, are you interested to make some aerogels? And I was like, why not, right? I mean, it's a free experience, so I'll just take it. So that's what happened. And after a few months of aerogel work, and afterwards I did a bit on zinc ion batteries over my year one summer, I realized that we could do something. And that's when Prof. Vincent was like, well, why not we write a review paper on zinc ion batteries? And the first reaction I had was how and why? Like, me write a paper? I can't believe it. So I was like, I guess I can give it a try and see how it goes. So I did after about, well, not 7 weeks, because I did take 7 weeks to write the paper, but it took 8 months to get it reviewed and published. And now it's available in Small Methods, the journal. My papers on the challenges and strategies on the development of zinc ion batteries. So yeah, I still to this day cannot believe that I had done this, but it's definitely an opportunity for you to, it's definitely a example to show that, hey, it's actually opportunities available for you if you come to material science to do all sorts of new and interesting things that you never think you could do. Like, for example, publishing a paper as a year 2 student. And what happened after that? Well, I did my Europes in year 2, Sem 1. I did my undergraduate research opportunities program. And in that program, I basically leveraged on what I learned in my review paper, and I was looking at the capacity of zinc ion batteries. So how am I going to improve, the performance of the zinc ion batteries to make it competitive to the batteries we use today? And that was the first time I used a scanning electron microscope, that $500,000 to $1 million machine that Prof. Blackwood was so worried that I would break, but actually I didn't. I did play with it for a while, but I'm so glad I didn't break it. I was nervous, but we got there in the end. And what's next after that? So I am actually a student in Residential College 4. So I'm under the University Town College program. And in Residential College 4, we are focused into the systems thinking and systems dynamic approach. And of course, we have our own residential college life whereby we have formal dinners, we have get-togethers, you have everyone encouraging each other, it's a nice environment. And of course, you have me graduating, well, quote unquote, because you have 2 years guaranteed stay in Residential College 4. And then the third year, I'm hoping I can secure it. So we'll see how that goes. So what did I do in Residential College 4 other than these things? So I actually co-founded a CCA, quote unquote. We call it Orca Stories, and we launched our first storytelling competition, which RC4 financed. And we actually launched a student book called The Force. So it's under the pretense of illusion, based on student submitted pieces. And that's us, the entire editing team and the profs all gathering together during the book launch. It was crazy. It was really, really fun. And it was an experience I could never think I would do. That's for sure. What else do I do in RC4? I actually research in RC4. How? Actually, there's a module called Projects and Systems. So it's basically a self-initiated research project on system dynamics. And in that project, I'm not sure whether the word crazy would cut it, but enough to model Singapore's energy systems. So solar, hydrogen, electricity imports, and natural gas, and so on to 2050. The good thing is that the paper was accepted to conference. I'll be speaking at the International System Dynamics Conference in Chicago, actually a few months later. So I will be flying, and I hope RC4 will pay. Actually, they will, I hope. And paper, we are going to submit it to another journal. So hopefully that would be awesome. But yes, I think this just shows that taking a material science degree doesn't necessarily mean that you're limited to material science. You can do things outside, you can do research, you can publish a book. I'm doing a minor in econs because I love how economics can be used to improve your decision-making framework in materials, in your financial decisions, and so forth. So I like to end this with a Q&A, so later that would be after Harini. So don't be shy. I think all the staff would be leaving. So if you have any questions like how do I plan, what is the minor why did I pick that minor, or why did I pick these specializations, please let me know. We'll be more than happy to have a chat about it. So yeah, thank you.
Hey, thanks, Zhongwei. Thanks. I think you have a very exciting experience here in NUS in general. That's great. Happy for you. So I think before we move on to the Q&A for Zhongwei's part, I would like to invite Harini, our first year student going second year, to share with everyone her experience. Harini, are you around? You are, right?
Yeah, I'll just share my screen.
Okay, cool.
Can you all see my screen?
Yes.
Yes, okay.
Yes.
So I'll just... Okay, so before I start, I really like to thank you all for coming down here and on a Saturday morning and listening to all the student sharings and Prof Blackwood sharing as well. So I'm Harini, and I'll be also sharing about MSc at NUS. So more about me. I graduated from NJC in 2021, and I took the most basic subject combination, which is PCME. And now I'm a year 1 MSc student, and I've just enrolled in Innovation and Design program as my second major. So I'm going to start it in year 2, Sem 1. Yeah, I'm also in MSc Club as a student engagement member. Okay, so about us. My cohort is like a small and cozy cohort, just like 40 people. And honestly, everyone just knows everyone. And this is like our orientation pictures. Yeah. So before I go into the fun part of school life, right, let's talk a bit about academics, because that's definitely important, right? The first thing I want to talk about is school scheduling. So you can bid for your modules. The new terminology is courses, if I'm not wrong. And you can choose the time slots you want for your labs, tutorials, and some of the lectures also you can choose your time slots. And it's not in a first come, first serve basis, which means that as long as you're like smart about the time slots you go for, you can actually get your first choice schedule. And how to be smart about it. During my orientation, a senior sent like a really, really long message on how to choose the slots. And I'm pretty sure we will send that to you during your orientation as well. So keep a lookout for it. And one fun fact is that, like in my year 1, Sem 2, right, I only had 2 days of physical school. I feel it's a flex. I only had to go down to school on Wednesday and Thursday. So my Monday and Friday were all like e-learning lectures, own time, own target. So I just could like stay at home. But I did come to school much more often than 2 days because I had group projects and lab also. So yeah. The second thing I want to talk about are the lessons we have. In year 1, I had quite a bit of group work modules. So like, for example, there's this module called Project Fundamental, then Data Analysis, and EG1311 is like an Arduino module. And our labs for MSc are also group work. So all these group works, right, you'll have people from very, very different disciplines. Like I had a business student, an Archi student, students from like infrastructure and project management, and we were like in the same group, and it's quite fun because we all have like very different modules, and like we do love sharing about it. And I did get to make like good friends with them, so which means that like we go out and study during exam time, we go to cafes and stuff. And actually one of the modules in year 1, which is called DTK 1234, you will hear this module from the seniors a lot. It was like the main reason as to why I chose innovation and design program as my second major. Because like my tutorial teacher, right, the way he talks about like the way he talks about how he thinks like his innovative ideas and how he comes up with it kind of inspired me. And I love the way they train us to think. And that's something that I really took away from this mod. And yeah, that's like some of the group work modules you have. And obviously, if you're coming to MSc, I do need to give you a sneak peek into the labs, right? So these 4 labs are all from only year 1, Sem 1, okay? So we work on like solar cells, supercapacitors, metal organic framework, and 3D printing. And the thing is, even though there are some like, there's a manual of sorts where there are a few steps because we are not very sure of the equipment, Prof. Vincent likes us to go beyond, and like there's like if you can think of something crazy and you can prove it to him, if you can like identify an element and tell it to him, he'll be like more than happy to like have that in our lab reports. And one of the things that stuck to me from the labs is about the metal organic framework. So the thing is, right, they are just powders, okay? But then the surface area of them is like comparable to that of a football field. And like in all our lab presentations, everyone mentioned it in one way or another. And that really stuck to me from the year 1, Sem 1 labs. So yeah. Okay, now let's move on. So the first thing you will be expecting when you come into NUS is orientations. So I went for 2 orientations. I went for CDE Rec, which is an exposure camp to this huge freshman event. So basically it's like they design their own props, costume, and they also do their own choreo, and then put up this showcase in July to August, around there. And this is like an exposure camp for that. So it was a 3-day event where in like the first day we did some banner painting, and the second day we had some dancing, and we worked with tie-dye and created tie-dye scarves. And also on the third day we had like a sports day to get us more active, and we had water games also. Then the second camp I attended was definitely MSc camp. So it was also a 3-day camp. It was a more chill camp. We had, I think the first game we played was Burning and Building Bridges, and it has stuck with us since then. We keep playing it over and over again. And we also went around the whole school. So we explored like the Faculty of Science, we went to business school, med school, and we just like explored the whole school on foot. And then we ate at U-Town. And we also had a few games, like running games and all that. So yeah, before I mentioned that my CCA is MSc Club, right? So I'm in the Student Engagement Committee. It's a fairly new committee, but our job scope includes us organizing some industry visits. We like to connect with the alumni and connect the alumni to the current cohorts as well. And our aim is to also bond the year 1s to year 4s. So yeah, and some of the events that MSc Club have put up in the past year include like Sports Day, which Jongre participated in. We had like badminton and captain's ball. And then we also had an Angel Mortar event. And the fun thing about Angel Mortar, right, we opened it up to the master students. So a few master students actually participated in it. And like we set up a chat board where you can talk to everyone and like remain anonymous. And like we had a whole review party at the end. And we also had a bonding day at Fort Canning Park, which was like a free and easy day. Like we brought in some food, we had a picnic, we played frisbee, and we played some card games, and that was that. So yeah, there were many more events, but these three are like one of the few main events we had lah. So yeah, I was also part of Save the Egg, which is I think it's a outreach kind of event because we work with like poly students and JC students, and they had to build a launcher on Fusion 360 from scratch. And basically, they'll put an egg inside and then throw it across the whole sports hall. That's what happens. And they have to pray that it doesn't break or crack. So yeah, I was guiding two teams from Ngee Poly, and on the right are all the seniors who helped out for the event. So yeah, and my most favorite event of them all is the year 1 MSc bonding, and it was actually a new initiative by two people in our cohort, Anna and Shah. So basically one day they went to Prof Vincent and was like, can we organize a year 1 bonding event? Is it possible? And Prof Vincent was like, yes, go ahead. So that's how they started, and they came up with like a whole they got us like free windbreakers, free shirts, and like had a huge food spread with pizza, wings, and stuff. And they also decorated like the whole E-Cube where we had the event. And we did take down the balloons to take the first photo on the left. We destroyed the whole decoration, but it's fine. And yeah, it was a really fun day with games and all that. So yeah. So the thing about MSc is obviously my experience doesn't encapture everything that MSc and NUS have to offer. And the best thing about our cohort is that we keep learning more about each other and with each other throughout the year. Like for example, we have Branson here on the left corner photo who volunteers at Mindsville, and also he goes for Teach SG as well. And then he comes back to us with like these wholesome stories about his kids and his volunteering sessions, and they are really, really nice to hear. And then we have Ishan, who's into sports. She's in table tennis and is also in the also the co-press of NUS Golf. So do follow NUS Golf. She asked me to say that. But yeah, and we have Anna here, who's in Raffles Hall, and she likes to sing and perform. And they had a few like event nights where she performed. And even outside school, we have Justin, who works with model cars. He's super passionate about them. And he builds like mini cities by himself using like styrofoam and cardboard and recycled materials. So that's like a mini city he built himself. And I also do love cycling a lot. So sometimes I do take my bike out in the weekends, or I go for a small cycle around the neighborhood and stuff. So yeah, that's us for you. And I'm almost coming to the end of the presentation, but do join us for MSc Camp. Really come down. I'm an OGL, so yes, you have to come down. And it's called Voyage. So it's a 3-day camp. And yeah, I can't tell you the details yet. Just come down and find out. And some of the other camps we have, I just went around searching for a few camps NUS has. I'm also OGLing in CD, Reg Exposure, and Athlentor. So Reg Exposure, I've explained. Athlentor is a volunteering camp and it's cross-faculty. So you get to meet people from various different faculties like science, business, and so on. And you can just take a screenshot of this, like if you like, because I have all the Instagrams here. So yeah, these are not all the camps. There are more like NUS sports camp and stuff, but this can be like a starter kit for you.